Hey guys, so this video is going to be about those removable discontinuities. So whenever we have a graph, there's a potential for removable discontinuities. We also call them holes. So when we're factoring, if we end up with a factor in the numerator and in the denominator and they're the same, that tells us where those occur, because that ends up saying, hey, we take that factor and we'll set it equal to 0, and that will be where that removable discontinuity is. So if we look at our first question here, it says, okay, we have f of x is equal to a 2x minus 6 divided by an x squared minus x minus 2. So what we need to do is factor here. So we're going to say, okay, we have f of x, and on the top, 2x and 6 can both be divided by 2, so I'm going to factor a 2 out here. So 2 times x minus 3 divided by, well, this one we'll use our x box or the table. I'm trying to use Xbox because I think that's how you guys learned it. So here we're saying, okay, what multiplies to a negative 2 but adds to a negative 1? Well, it's going to be a negative 2 times 1. So down below we're going to fill in those factors, x minus 2 and x plus 1. So if I look here, there's no common factors on the top and the bottom, so that means we have no removable discontinuities. Meaning what we have here, these are actually vertical asymptotes. So then, in our next question, I'm going to go through this with you guys. There's a bit more factoring going on here. So with this one, we have this 3x squared plus 10x plus 8. So this one will require the full Xbox method. So we're going to say, hey, what multiplies to 24? That's the 3 times the 8, but adds up to 10. That's going to be a 4 times a 6. But because that 3 in front, we need to go back to that box and say, okay, well, what would multiply to 3x squared? We're going to have the 8 here. And these are the numbers we use to fill in those other boxes, a 4x and a 6x, because if I combine them, we would get back to 10x. So I say, okay, 3x squared and 6x, well, they can both be divided by 3 and an x. Here, a 4x and an 8, well, those can both be divided by a positive 4. Now if we go this other direction, 3x squared and 4x, those can both be divided by an x. 6x and 8, well, those can both be divided by a 2. It's going to be positive. So if I rewrite that top part of my function down below here, so far we have f of x is equal to, we're going to have a 3x plus 4 times an x plus 2. So now factoring that bottom part, we would say, okay, what multiplies up to a negative 8 but adds to a negative 2? It's going to be a negative 4 times 2. So in the bottom here, we'll have an x minus 4 times an x plus 2. Well, these two factors on the numerator and denominator, they're the same. So saying, hey, technically these can cancel out, but there's going to be that removable discontinuity. And it's going to be at x equals, we're going to say, okay, I'm going to take that factor x plus 2, set it equal to 0, x equals negative 2, so at x equals negative 2. That is it for removable discontinuities. If you have any questions, as always, contact me, or internet has a lot of resources on it. You can always watch the Southeast video as well. It's going to be very similar, same problems, maybe different wording though. Do what you need, and good luck.